Math Standard 8, we're still in the geometry standard. We're still looking at applying our Pythagorean theorem, which by now you should know is a squared plus b squared equals c squared. And so what Learning Target 2 is going to ask us to do is to apply this Pythagorean theorem of a squared plus b squared equals c squared to find unknown sides lengths of right triangles. So you could be missing, if we review here quickly. So if we have our triangle, okay, our vocab words are legs of the right triangle, and these are the two legs of the right triangle that make up the 90-degree angle. And then we have our hypotenuse, which is across from the right angle. So when you look at the Pythagorean theorem of a squared plus b squared equals c squared, and you're thinking about where does a, b, and c come from, well, a and b are the legs. And don't get all concerned about which one you're going to label A and which one you're going to label B. It mathematically doesn't matter. You just decide. A and B are your legs, and C is always the hypotenuse. So A and B and a C. So we're going to look at the first problem here. So the directions are to solve for the missing side length using the Pythagorean theorem and round to the nearest tenth if needed. So right away I notice that I have a leg of 5, I have a leg length of 10, and I'm missing my hypotenuse, my C. So I'm going to start by writing the equation, the Pythagorean theorem. So I have a squared plus b squared equals c squared. And I'm just going to draw the squares. I'm not going to be able to draw full squares here. But I'm going to draw the squares off just to get used to kind of understanding that. So I see 5 and 10. Again, it doesn't matter if that's my A or my B. But remember, we're going to square them because mathematically, we're trying to find the area of these two squares. So we're taking this area with a length of 5. We're squaring it, and that gives us 25. So I can write that here. And then we're taking this 10, and we're trying to find the area of this square. So we're going to take 10 and squared it, which is 100. And I just need to erase, because right here, I should have put 10 squared. And that's going to equal what we don't know yet. So we have 10 squared, which we just found here is 100. And then that equals c squared, the unknown. Well, mathematically, we know the Pythagorean theorem. We know that this small triangle area, which is 25, and this leg over here, which the area of the square is 100, if we add those together, it's supposed to equal the area of the square. So just looking at it visually, 25 plus 100 is, we know that c squared equals 125 because the adds up the two small squares. So I could write algebraically here, I know that c squared, which I just wrote up here, but I'm going to write it down in my steps, equals 125. Now, I don't want to know what the area of the square is. I just want to know what this length of c is, the hypotenuse. So to undo a square, or to do the inverse of a square, you square root. So we're going to take the square root on both sides here. So that's going to undo the square and square root are inverses or opposite operations, so that just gets rid of both of them. They undo each other. And then in our calculator, you're going to take the square root of 125 and then press equals. It says the directions to round to the nearest tenth if needed. This is an irrational number. It goes on and on forever, so we're going to round to the nearest tenth. So we're going to look at 11.2. And I'm going to change this sign to approximately because it's not equal exactly to, it's approximately. So the bottom here, the missing length is approximately 11.2 units long. So our hypotenuse. Next problem. When we look at it, we notice right away, this looks like where my right angle is. So this is a leg. I'm missing a leg, which we have labeled as A, and my hypotenuse is 12. So a squared plus b squared equals c squared. Again, if it helps you, you can make the squares off the sides if you need that visual to kind of work your brain through this. Otherwise, you can just do the algebra part. You do not have to keep drawing. So a squared is the unknown. B, which is your other leg, has to be 9 squared. And c, the hypotenuse, is 12, so that's 12 squared. Don't know a. B, We know that the area of this square would be 81 because 9 squared equals 81. So algebraically, I'm going to write that there. Equals, and right here, this is 12. So 12 squared is 144. And then we're just going to solve algebraically because we know that this unknown plus 81 has to equal 144. So I know to inverse that or to reverse it so I can get the a squared by itself, I'm going to subtract 81 from both sides. Since we're adding 81, I'm going to subtract it to get rid of it. So a squared equals 63. And then remember to get rid of this square because I don't want to know. We know that 63 is the area of the square, but I want to know what just a is. I know a squared equals 63, but just a. So you're going to square root to undo the square. So that undoes that and gets a, and then is equivalent to, I'm going to type it in my calculator. I'm going to notice that again, it's irrational, which means it's not a rounded number. So I'm going to round to the nearest tenth, which is 7.9. So the missing length, which is a leg, is 7.9 approximately units long. In our last example, so I'm going to solve for the missing side. So my brain goes, okay, what's missing? So I look at it. Here's my right angle. So this is one of my legs. Oh, look at that. One of my other legs, this time I'm going to call it B, just so I can have the other one missing. And I know my hypotenuse. So I'm going to start with my Pythagorean theorem. And then I'm going to plug in what I know. Again, if it helps you to draw the squares off, you're more than welcome to. A is going to be 3 this time because I made this missing leg B. So I have 3 squared plus the unknown squared equals, and this is my hypotenuse, which is 6. And I'm going to square that. So the area of this square, which is 3 squared, which is 9. So we have 9 plus, I don't know yet what the area of that square is, and 6 squared equals 36. So I know that equals 36. So solving algebraically, we want to know what b squared is. So we're going to subtract 9 from both sides. Because that kind of makes sense. You're going to reverse this as you know this is 36 is what I want it to equal. We're going to take away the 9 so we know how much we have left. So we get b squared, the unknown square area is equal to 27. So b squared equals 27. You can see that algebraically here, and you can see it algebraically over in the square. To get rid of the square, the opposite or the inverse is to square root. So we end up with b, and we're going to type that in our calculator. Again, it's not a whole number, which means it's irrational because it doesn't terminate. So again, we have to round to the nearest tenth because I don't want to write all those numbers down. And it ends up being approximately 5.2. So the missing length, which is a leg, is approximately 5.2 units long.